today we'll start about the zener diode. Zener diode is just like a diode only. Okay, but what is the difference between the normal diode and the zener diode? That zener diode works as a reverse bias only. It will not work in the forward bias condition. So mark that important. Why? Because one of the numerical will 100% come from the zener diode in the n term and in midterm also. N term mein every time it comes. Okay. So I'm moving direct towards the question. Which type of questions will come in your paper? So we'll have the basic structure of zener diode is like this. Zener diode symbol is like this, for diode, and then mark it Z like this. Zener diode. Okay. So suppose if I mark it zener diode. As I told you, zener diode works in reverse bias condition, so I connected zener diode as a reverse bias. The zener diode, so like this. This one is the load resistor. Now see what is the main purpose of the zener diode. It will work as a voltage regulator. You know what is voltage regulator or I can say what is voltage stabilizer? Tell me if you know about it. Is used in your AC or refrigerator, basically in AC, voltage stabilizer. So what is the work of that voltage regulator there? That AC required 220 volt of output, right? But if suppose from the government side 200 volt will come, then in that case AC will not work, right? And maybe 200 volt can damage the AC, right? And suppose like from the government side, from the supply side 240 volt comes, again the AC requirement is 220 volt. So whatever will be the input voltage, whatever will be the variable voltage, a voltage stabilizer or voltage regulator work is to maintain the constant output voltage. Okay, what is the basic function of that? That is, it will maintain constant output voltage. Understood? So whatever with the input, output voltage across the load must be constant. So this is the basic structure. This is the supply voltage. Supply voltage is denoted by Vs. In some of the notation they can denote it by V in. V in is the input voltage, or we can say Vs is the supply voltage. So both the meanings are same. This one is the zener, so the voltage across zener would be Vz. This one is the load resistance. Okay, like I told you, I gave you the example of AC, so AC is the load, right? So we want the constant output across the load resistance, and load resistance is denoted by the term RL, right? And here the voltage across the load will be denoted by VL, correct? Or sometimes they called it as V naught. VL is the load voltage, V naught is the output voltage. So you should know the notations based on that. They can use any of the notation. Next one, this one is the resistance which is connected in series with the supply voltage. So sometimes they called it as RS, the series resistance, or the supply resistance, or sometimes they called it as a input resistance, right? Understood? So basically we'll have two category of voltage. One is the zener voltage, another is the load voltage, correct? As I gave you just example that load voltage is constant, that we require as 220 volt. Sometimes input voltage can be less, like 200 volt, or sometimes input voltage can be more, that is 240 volt, right? So input voltage can be less or can be more. If the supply voltage is less, then accordingly zener voltage is also less. Okay. So From that, we are dividing this question into two category. Maybe the zener voltage must be greater than the load resistance, okay, and maybe the zener voltage must be less than the load resistance, right? There are two possibilities, that Vz must be greater than Vl or Vz must be greater than less than V. So let's draw the diagram. If Vz is greater, right, means voltage across zener is high, then current across zener is high or low? Tell me. If voltage is high, it's not Ohm's law, and this will apply this case. P is equal to Vi. If power is constant, voltage increases, then current decreases, and vice versa. Okay, so in this case, Vz is greater than Vl, means Vz is high, right? So if Vz is high, then in that case Iz is low. So how much it can be low? As much as low possible, that would be 0, right? So we can consider Iz as 0. Iz as 0 means no current is flowing across the zener diode, correct? So in this case, we can consider that if no current is flowing across the zener diode, there is an zener diode will behave as a open circuit. Then only in this case no current will flow, right? So in this case, basically if Vz is high, then we consider zener diode as a reverse bias, and in reverse bias no current will flow. So in this case, we have to calculate the formulas based on that. So this one is, as you know, IL, this one is the supply current, this one is the supply voltage, this one is RS, and this one is RL, right? So from that we need to calculate the value for the VL. VL means the voltage across load. That is what we want, exact, correct? So now as you can see that RS and RL is in the series circuit, and in the series circuit, to calculate the voltage, can we apply voltage division rule that you have studied in the BT? Did you know about the voltage division rule? Voltage division rule, right? So what is this voltage division rule? Whenever the circuit's resistance is in series, then we can apply to calculate the voltage. Like suppose we'll have R1, R2, R3, and the total voltage is V, and we need to calculate the voltage across R2. So what is the formula according to the voltage division rule? That is total voltage multiplied by R2, in whichever branch we need to calculate the voltage, divided by the sum of resistance which are connected in series. So this is the formula. Can you similarly tell me the formula for the voltage across R1 by using voltage division rule? R1 plus R2 plus R3, right? Note down this thing. So this is the formula, we'll get it for the VL, right? By applying the voltage division rule. And in this, as you can see that no current is flowing across through zener. So can we consider Is is equal to IL? Because the resistance are in series, so current would be same, right? Similarly, we'll have another formula based on this. If we want to calculate Is, right? Like in this case, Iz is 0. If we want to calculate Is is according to Ohm's law, how much? V divided by R, right? Here the voltage is Vs and the resistance is Rs plus RL, correct? So we'll use every time these formulas when we'll have this condition. Understood? Now back to the next case, if Vz is less than Vl. If Vz is less, then in that case there must be some amount of current flowing over there. Right? So in this case I am drawing the diagram again. This would be Rs, this would be RL, this would be the voltage across zener would be Vz. Current flowing in the zener is Iz, current flowing in the load is IL, voltage is Vs, right? And here the current flowing is Is. Understood? So in this case, as you can see that these two things are connected in parallel, right? So first again we need to calculate voltage PL, that is what we want. So as you can see that these two are connected in parallel, and as you know in the parallel voltage is always same. So can we say that VL is equal to VZ? Can we say that VL is equal to VZ? Next thing we'll have Is is equal to Iz plus IL. If I'll apply the Kirchhoff current law over there. Is supply is like here the Is value is this one, here the Is value is this one. Correct? Again, if we want to calculate Is with the another formula in terms of V by R, so Is is how much? Like the total voltage minus the voltage consumed by the load, right? That is Vs minus VL divided by Rs. Because suppose I'm giving you an example, like if you have given 200 volt, okay, and the voltage consumed by load is 20 volt. So how much is the left voltage? That left voltage is consumed by this resistance only, Rs, right? Okay, I'm telling you again. This up to here you understood? Okay, this is the Kirchhoff current law which you have studied in BT. Like I am assuming that you know the BT. I am telling you again. This one you understood? How VL become equal to VZ? Because here is VZ, the voltage across zener, and here is VL, the voltage across load resistance. Both these things are connected in series or in parallel. So if they are connected in the parallel connection voltage is same or different? Same. So can we say that VL is equal to VZ because they are both in the parallel condition? Okay. Now if you remember the Kirchhoff current law which you have studied in BT, basic electrical technology. Did you remember the statement of nodal analysis or Kirchhoff current law? Okay, that statement states that sum of incoming current is equal to the sum of outgoing current. So can you tell me, like suppose this is a node A, how much is the current entering in this node? Is, Iz or IL? Is entering is equal to the sum of current leaving the node. Which current is leaving? Iz, IL or Is? Iz. And what about IL? IL is leaving or entering? So can I write down this statement? This is the another formula. Okay. Now I want to calculate the value for Is in terms of V by R, right? So suppose if I'll give you one example, we want to calculate the voltage across this one. Then how much is the voltage? Like I gave the total voltage as 200, and from that load consumed by the voltage consumed by the load is 20 volt. Okay. So how much is the voltage consumed by Rs? Can you tell me? Total you have given as 200. load like AC, like supply voltage in your home is 200. From that AC consumes 20 volt. So rest of the voltage is consumed by this resistance now. So how much is the voltage consumed by the RS? Voltage consumed by RS. One second, I'm making it more clear. This is VS, this is RS, this is RL, this is V. Okay. So I am saying the voltage, total voltage is given by supply voltage is 200. And I told you the voltage consumed by the load resistance is 20 volt, right? So how much is the voltage consumed by RS? In the series connection, V is equal to VR plus VL, VR plus VR1 plus sorry VR2. तो अगर हमने टोटल वोल्टेज 200 दिया है उसमें से 20 वोल्टेज इसने ले ली तो बाकी लेफ्ट ऑफ द वोल्टेज इज कंज्यूम्ड बाय दिस और नॉट. So how much it is? 180. So how did you do that? 200 minus 20. So 200 is the supply voltage. 20 volt is the load voltage. So can I write down Vs minus VL? Now understood? So Is is how much? Vs minus VL divided by the resistance Rs. I convert I of S in terms of V by R. Okay? Now understood? Note down this formula. Like this is the question from September 2023, your midterm exam. In this they have given, this is question number 13. They have given RS 120 ohm, VZ 5 volt, RL 250 ohm and voltage, input voltage vary from 9 to 15 volt. Now we need to calculate IZ minimum and maximum. Okay. So first thing, whatever they will give you for the zener diode, you have to draw the same standard diagram and just always write down the values which they have given in the diagram. Okay. First thing. Next thing, they ask you IZ minimum and maximum. If you will take 9 volt as the voltage, then you will get zener current as a minimum. Okay. If you will take 15 volt, then you will get the zener current as the maximum. Okay. So 9 volt will get IZ minimum, from 15 volt will get IZ maximum. Understood? So for IZ, first of all we have to see what is IZ. Whenever they'll give you the minimum and maximum condition, we'll have to follow this one part, the second one, always. Okay. So now first we need to calculate IZ. Back to this one, the second part. As I told you, all the formulas, only this formulas will use. From here we need to calculate IZ. So can we calculate the value of IZ from here? So IZ is how much according to this formula? Yeah, IZ is equal to IS minus IL, right? So can I say that IZ minimum is equal to IS minimum minus IL? Can I say like this? IZ minimum, then in that case supply current would be minimum only, right? And minus load current is constant because load resistance is constant, so it will be constant only. Correct? Any doubt up to here? So for that, yeah, I'm telling you, for that we should know about the IL, right? Back to the formula page. IL is how much? Write down one more thing, that according to Ohm's law, VL is equal to IL into RL, right? So can we say that IL is equal to VL by RL? So from this we'll get the formula IL is equal to VL by RL, right? So do we know the value for RL? 250. Do we know the value for VL? No, they didn't give you. Back to this page. Now as you can see that in this case always VL is equal to VZ. Means whatever will be the zener voltage, that would be equal to the load voltage, right? So let's see if they'll give you the zener voltage or load voltage. Tell me. They have given the zener voltage in the question. So can we say that VL is equal to VZ? So VL is equal to VZ is equal to 5 volt. Correct? So if I'll solve it, that is 5 by 250, that is 1 by 50. Right? It's an ampere. If I convert it into milliampere, then it would be 20 milliampere. Generally the load current is very less, so convert it into milliampere. Okay, so we got it here. IL is a 20 milliampere. Now tell me, any doubt up to here? Very good. Now next we need to calculate IS minimum. Back to this IS formula, as I told you, how much? VS minus VL divided by RS. Okay, I'm writing down the formula over here. IS would be equal to VS minus VL over RL. As I told you that in this case, if we'll take IS as a minimum, suppose we'll take VS as a minimum. Okay, so VS minimum, then in that case VS minimum is how much? 9 minus VL is 5, right, divided by the load resistance is 250. Correct? Now tell me, any doubt up to here? Now solve it and tell me the value in terms of milliampere. Yes. So it was, sorry, RS, that is 120 ohm. If I'll solve it, that would be 4 by 120. That will become 33.33 milliampere, right? So this one we got it as, we'll use minimum voltage, that is 9 volts. So we'll get the minimum current, supply current, right? Obviously, if you'll use minimum supply voltage, then you will get minimum supply current only, correct? So you can write it down over here. That would be IS minimum is 33.33 milliampere. Correct? So in this case, if we'll solve it further, then tell me how much is the value. Then we'll get it as 13.333 milliampere as the IZ minimum. Correct? So we got the one value of IZ minimum. Similarly, calculate the IZ maximum, but this time you have to use 15 volt. Understood? Another question is, again I'm teaching you from a question paper only, that is March 2021. It's an end sem paper. Okay, I am drawing the diagram. Again, whether they'll give it to you or you have to draw it, the diagram is same. There is no changes in the diagram. In this they said this is V in, this is RS is equal to 3.75 kilo ohm. The voltage across zener they have given as 50 volt. VZ is equal to 50 volt. RL they haven't given, but they give you the current, that is 25 milliampere. They said find the limits for V in, means we need to calculate V in minimum and we need to calculate V in maximum. Okay, so for that they have given you the two possible cases. IZ minimum as 5 milliampere, consider the units also, and IZ maximum as 40 milliampere. Okay, try this question. In this case, IL is given, L is given 50 volt, because VL is equal to VZ. So we can calculate RL, right? VL is equal to IL into RL. So that would be 50 divided by 25 ampere. So that would be how much? 2 kilo. Correct? Okay. Next you need to calculate V in. As you know, the formula for Vs is how much? Like Is is equal to Vs minus Vl divided by Rs. Correct? So VL we already know, Rs we already know, but we don't know the supply current. Correct? So supply current, how can we get it? Is is equal to Iz plus IL, right? IL you already know, 25 milliampere. Iz, if we'll take Iz minimum, okay, then in that case you will get Is maximum. Yes or no? It will be contradict or not? No, sorry, if we'll take Iz maximum, then it will be Is maximum. Correct? Suppose it will be Iz maximum. Iz maximum is 40 milliampere. Then in that case, you will get Is maximum. So 40 plus 25 is 65 milliampere. You can substitute the value 65 milliampere over here. Then from that, you will get VL minimum. Is it the right procedure? Is it the same procedure which you have done? Like the first step we calculated RL, right? Then after that, this part Is is equal to Iz plus IL. IL we already know. Is we don't know. Iz is given. Maximum 40. So we know the formula for Is. Then the next step, Rs we have given. VL we know. Is we have calculated, right? We can substitute the value of Is over here, then we'll get Vs. So how much we get Vs? That is 65 is equal to Vs minus 5 divided by Rs is 3.75. Correct? So I use this maximum value, we'll get Vs maximum over there. If I'll use minimum value of the current, then we'll get Vs minimum over, right? So from this formula we'll get Vs maximum. Now solve it for the Vs minimum and then tell me the value.